Hi everybody, welcome to part 2 of volume. In this section we're going to look at applying the volume formulas, and typically what that means is either word problems or solving for a missing part of a shape. So let's get started. In the last video I emphasized what the volume formulas were and what they were designed to do. And the other thing I emphasized was maintaining the symbol of pi as opposed to converting it to 3.14. I'm going to maintain these views here, and I think in doing so it's going to make working through these problems a lot simpler for you. Decimals tend to be harder in this context. So let's take a look at the first example. In this first example, I need to find the height with the given volume. So for whatever reason, we don't have any context here. I need to find the height of this cone. So I'm going to do that by invoking the formula for the volume of a cone. Okay, so the formula for the volume of a cone is volume equals 1/3 pi r squared times height. And now what I'm going to do is I'm going to insert the values that I know. I know that the volume of my cone is 50 pi, so that would be V, and I will replace V with 50 pi. The 1/3 pi comes down, and now what I'm going to do is to substitute the radius, or r, with 5. So I have 5 squared here, and I am looking for the height. Okay, so this is the same as solving for x or taking apart any equation. We are going to now solve for h. Let's get started. There's legitimately a number of ways to go about this. And the first thing I'm going to do is I am going to square the 5. So 5 squared is 25. I don't really have to do this step. I could square root later if I like. But one of the things we need to work on when we do math is find our way to make things easier for ourselves. I brought down the 1/3 pi and the red h and the blue 50 pi, which is the volume. For this particular example, I am going to isolate everything one step at a time. So hopefully that makes the process of taking apart an equation or solving equations easier to understand. Every term on the right side of this equation is multiplying. So that means one at a time I have to undo everything or turn everything into a 1. The way we're going to turn everything into a 1 or undo everything is by division. So I am first going to divide pi. Pi is the easiest thing for me to divide because pi divided by pi is 1. Then I'm going to divide by pi here, and that is also going to become 1. So 50 pi will become just 50. So now I brought down the remaining, which is 1/3, 25, and h. I'm going to divide out the 25. Dividing out the 25 will make this problem a little bit simpler. So, and notice as I'm dividing out 25, turning this into a 1 so it no longer affects the side of the equation, and I'm dividing out 25 here, I'm making choices. 50 divided by 25 is 2, and I'm going to bring down what I have left. So now I have to just get rid of the 1/3, and I'm also going to turn that into 1 by division. But in order to divide a fraction, you need to multiply by the reciprocal, so I am going to multiply by 3/1 to both sides. That's going to give me 1. So 1/3 times 3 over 1 is 3 over 3, which is 1, which once again no longer affects the right side of the equation. Now I have to multiply 3 over 1 times 2. And the way we do that in the textbook is I could put a 1 underneath and then multiply across. So 3 times 2 and 1 times 1, which will give me 6. So that means 6 is the height of the cone. Okay, let's go to the next example. Okay, the next example wants me to find the radius given the volume of a sphere. So the volume of a sphere is V equals 4/3 pi r cubed. And I've been given the volume of the sphere, so that is 36 pi. I'm going to bring down the parts of the formula that I cannot change, and I am looking for the radius, which is cubed. We're going to apply a lot of the same rules we did before. As I mentioned before, the first thing I like to remove from both sides of the equations, whenever possible, is pi. Once again, this becomes a little bit more difficult if you have a decimal. The pi symbol is making everything easier for us by just dividing out into 1, because pi divided by pi is 1. And I've brought down what I have. Now comes the next step. I have to relieve myself of this 4/3. I'm going to do that the same way I did that in the previous example, by dividing out the 4/3, or in technical speak, multiplying by the reciprocal. In this case, the reciprocal 4/3 is 3 over 4. If you're figuring out that all the reciprocal is in the world of fractions is flipping the fraction when you multiply them, the answer is correct, because the goal is when you multiply these fractions together, you're getting to 1. And 4 times 3 is 12, and 3 times 4 is 12, and 12 over 12 is 1. Now, we have to multiply 3 over 4 times 36. Thanks to the use of my calculator, 3 over 4 times 36 is 27. And I'm bringing down the remainder of the formula, which is r to the 3rd power. Now, I'm not done yet. R is not isolated. It is still to the 3rd power. We want to know what a single multiple of r is. And the way I have to do that is I have 2 choices. And the simplest choice for most of us will be to cube root. So I am going to cube root both sides. Cube rooting is the same as rooting to the 1/3 power. And these exponents technically multiply when you do that. So 1/3 times 3 is 1. But to keep things in simple terms, you cube root, r is equal to 3. Okay, the next example. This is a compound shape. It is called a capsule, and it is a sphere split in half with a cylinder sandwiched inside. So we're going to have to use 2 volume formulas. Okay, so the volume of a sphere is V equals 4/3 pi r cubed, and the volume of the cylinder is V equals pi r squared times height. And now what I'm going to do is I'm going to fill in the information that I have. So I know that the radius of both the sphere and the cylinder is 6, so I'm going to fill that in. And I know that the height is 5, so fill that in. And I will fill in everything around that. So I have V equals 4/3 pi, then V equals pi 6 squared times h. And be careful, because if you didn't notice, I accidentally left off the cube in the 6 cubed. So now I'm going to get both answers. 6 cubed is 216, and I'm going to multiply that by 4/3. Notice I'm ignoring the pi, so I get 288. Now I'm going to put the pi back in place, and because pi as a symbol is a non-like term, I could just place pi right next to 288. I mentioned this in part 1, so if you're unsure about how I handled this, go back and visit part 1. I'm going to handle the cylinder much the same way. I have 36 because 6 squared is 36 times 5 is 180. And just like before, I bring down all of my terms. So now I have to add my two answers together. Essentially, because pi is just along for the ride, I could actually ignore it. The way I wrote this isn't proper. I really should include pi, but I'm going to make it a different color. All I have to do is add 288 plus 180, which is 468. Then I just have to add the pi to the end. Once again, not to keep repeating myself, but this problem becomes a whole lot more difficult if I choose to make pi 3.14. Not only that, but going back to it, we don't know what this capsule is used for, and we don't know the level of precision we need. So the simplest solution is to give the answer in the most precise format. Alright, let's go to the last example. Okay guys, we're going to start with the volume of a cone, and in this case we are going to use the volume of a cone, but we have a bunch of issues here that we're going to need to address. And those are the fact that we don't have a height or a radius. And in order to find the height of the radius, we're going to need to use sine of theta, cosine of theta, to solve this problem. Now, if you're unfamiliar with these terms, you can go back and look at the videos on trigonometry, or go look through the interweb for other videos on trigonometry. So I'm going to start this off by first labeling my triangle. Now you have to be really careful because these labels can be a little bit confusing. So this is my reference angle, and I have this is my opposite side, this will be my adjacent side, and this will be my hypotenuse. Let's not confuse that with height, because this diagonal line is actually typically referred to as the slant height. So first thing I'm going to do is let's use sine to find our actual height. So that is going to be sine 53 equals, I guess I'll call it h over 5. In my video, I spoke to the powers of cross multiplication, so that is what I'm going to do here. So 5 times sine 53 is 5 times sine 53. And I'm going to need my calculator to tell me what that is. And the answer is 3.99, and I'm just going to round that to 4. Going back to the whole issue with changing symbols, you could round subjectively. Now, from there, I have to find the radius, and I'm going to use cosine to do that. I'm going to use the same exact process as I did before, so I'll write it up here in the corner. So we have cosine 53 over 1 equals, I guess we'll call that r over 5. Then I'm going to cross multiply. I'm going to get 5 times cosine 53 equals r. And I'm going to ask my calculator, and my calculator told me it is 3.00 or 3. With that being said, I have found the dimensions I need to complete the volume formula. And I could essentially do this one by hand, because 3 squared is 9 times 4. Then I have 1/3 equals pi. 1/3 times 9 is 3. Pi times 4. Then 3 times 4 is 12 pi. And that is my answer. We have found the volume of this cone. Okay guys, I hope you guys have found this video helpful.